Sun is a fiery ball. How can Aditya reach there? If you are going to launch it on September 2nd, how long it will take to go there? What will this spacecraft study on Sun? What's its use? After the success of Chandrayaan, Aditya L-1 is the dream project of ISRO. After placing Aditya L-1 in its parking spot, India will join the club of nations which have space telescopes observing the Sun. The United States of America, European Space Agency, and Japan have space observatories investigating the Sun and its dynamics. With Aditya L-1, India will join as the fourth country to do so. The Indian craft will study all this very intense solar activity. The solar storm, the solar flare, and the coronal mass ejection will result in geomagnetic storm. And the Aditya L-1 will give us a deeper insight into this dynamics. When will Aditya L-1 reach its spot? ISRO does not have a very powerful rocket like some of these developed countries. Therefore, we are going to use the same technique of slingshot which we used in launching the Chandrayaan-3 to launch Aditya L-1 to its parking slot. It's going to take roughly more than 100 days for the craft to be launched and taken to its parking slot called as L-1. Chandrayaan landed on Moon. What about Aditya L-1? Will it land on Sun? No, it won't land on Sun. Actually, it will be parked in a place between the Sun and the Earth in a point called L-1. L-1, what's so unique about this point? L-1 or Lagrange point 1, that's about 1.5 million kilometers from Earth. The distance between the Sun and the Earth is 151 million kilometers. Now look at this imaginary line between the Earth and the Sun. Every point here, it will experience the gravity from Earth pulling towards it and also the gravity from Sun pulling toward that, right? So there should be a point somewhere in the line where the gravitational pull of Earth is equal to the gravitational pull of Sun, right? That's a point called Lagrangian point 1 or L1. That's where we are going to place this Aditya L1 in that spot. But why did we choose this spot? As we said, in this spot, the gravitational pull of Sun and the Earth are equal. Therefore, when the Earth goes around the Sun, this point will also move along. It will also revolve around the Sun. However, the craft will always be pointing towards the Sun. Therefore, if there is a solar storm or any such violent activity emanating from Sun, Aditya L1 will sense it first before we see its impact on Earth. Therefore, we may probably be able to get a pre-warning on probable solar storm. Solar storm? What's it? You know, when the Sun emits charged particles at high velocities and great densities mixed with magnetic field, that's called solar storm. Space is empty. How can there be a wind? That's correct. On the surface of Earth, we call the movement of air as wind. When we talk about solar wind, what we mean is the charged particle mixed with the Sun's magnetic field emanating in all direction from corona at great speeds of 200 to 600 kilometers per second. This stream of particle traveling at high velocity is what we call as solar wind. But how and why solar storm occurs? The Sun is revolving on its axis. Therefore, what happens is that some of its magnetic lines get twisted. When this twisted line breaks, forms new connections or emanate from it, we have solar storm, solar flare and coronal mass ejection. When there is a solar storm, the charged particle can move even at great speeds of 800 km per second, even higher. At times, the twisted magnetic lines can form new connections. When this happens, a flare of X-rays, gamma rays, ultraviolet rays, visible light is emitted with colossal energy. This is solar flare. Sometimes the twisted magnetic lines can expand out of the surface and burst out. The erupting magnetic lines carry with it considerable amount of plasma from sun surface. This is called as coronal mass ejection. All these three violent phenomena will result in speeding charged particles with high density. If they travel in the direction of Earth, they can come and hit the Earth's magnetosphere. The magnetosphere is disrupted and we have what is known as geomagnetic storm. Are the geomagnetic storm harmful? No, not for you, not for me, not for life on Earth. However, the satellites which go around Earth may get affected. Satellites in space, in particular, the electronics and the solar panel can be affected by strong geomagnetic storm. Space travelers need to take extra precautions. The magnetic storm can also disturb the shortwave services and the GPS may face temporary disturbance. At times, electrical supply in higher latitude may get disrupted and power outages may occur. This is why we are interested in understanding and predicting space weather. What is space weather? Measuring the changes in the density of charged particles which are coming towards Earth and the changes in the Earth's magnetic field is called as space weather. Predicting adverse space weather is essential to keep the thousands of satellites orbiting Earth safe from high dose of radiation. Other than space weather, will Aditya L-1 tell us something deep about Sun and its dynamics? Yes, there are lots of mysteries about Sun. Let's take one. We know that if there is a fire and you stand near it, it's hot. But the moment you move away from it, the temperature falls, right? Now, let's look at the Sun. The surface of the Sun is about 5,600 degrees. Now look at this corona. It's like the outer atmosphere of the Sun, like our atmosphere. One would expect the temperature of corona will be less than the surface of Sun. But surprisingly, it's 1 million degrees. Why corona is so hot? We are not so sure. We are not so clear. There are lots of unknowns here. Perhaps some of the studies, data and investigation by Aditya L-1 will reveal lot more about the dynamics of the Sun and how Sun works. How will Aditya L-1 study Sun? A set of scientific instruments which is placed in Aditya will study the activity of the Sun and its dynamics, whereas few instruments will study the space weather near its parking spot. Visible emission line chronograph, an instrument on the Aditya L-1 will study the changes in the solar corona and the dynamics of coronal mass ejection. This instrument has been developed by Bangalore-based Indian Institute of Astrophysics, an autonomous organization under the Department of Science and Technology, in close collaboration with ISRO. The Solar Ultraviolet Imaging Telescope will image the photosphere and the chromosphere in ultraviolet wavelength. This will give us deeper insight into the coronal mass ejection. Energetic X-rays are emitted by solar flare. This will be examined by the solar low energy X-ray spectrometer and high energy L-1 orbiting X-ray spectrometer. Aditya Solar Wind Particle Experiment and Plasma Analyzer Package for Aditya will monitor some of the aspects of space weather near the parking slot. The magnetometer will monitor the changes in the magnetic field. These will help forecast dangerous magnetic storm heading towards the Earth. After successfully landing on the moon, ISRO eyes the sun.